Hello and welcome. Here we are going to find the frequency of our audio files using the FFT algorithm. So before that we need to pad our all audio files to the same length. This is the code for padding these all audio files to the same length. We take the length as 7 and we have used 3 modules mainly: wave, PyDub and globe. This is the location where all the files are stored. So first we globe all the files together. Globing means we take all the files from a folder, here pdb, then we take them together as a list. Then only we can access the files using a loop. So all these file names are put into a list. Each item holds a file name. So here from that list we are taking each file's path, and we are opening each file. Then we are getting the frame rate and n frames from each of the file, and we are calculating the duration of each file. After that we calculate the required duration of the null file, that is to be padded to the original file, by taking the difference between the original, that is 7 seconds, and the duration of our file. Now we get the duration, and that duration we are converted into milliseconds using this version. Then we are taking the audio, that is wave file, and padding our silence with the original audio file, and then we are exporting and saving it to this location in PDC. Now let us run the code. Python test load file. Yes, or PDC. It's quite a large file, about 2000, about 2700 files. I think it's done. Yes, okay, it's done. Now since we have the padded files, we must now calculate the frequency of each audio file, for which we have another program. We edit 2.5. Yes, this is the program for finding the FFT of the frequency using the FFT algorithm for each file. This is a little bit larger code, so I think it will be easy if I explain the main parts of the code. Our program starts here. First we import required modules: wave, struct, numpy and globe. So first we globe all the files from the PDC, that's the location where we stored all our parent files. Then from that files we take each of the file. Now this line means here path denotes this line, so we are reading that portion of the string which comes after the fifth backslash, sorry, front slash, fifth slash. Then we calculate the frequency using this ifreq, that function. Here, as we can see, ifreq returns as a list. Okay, so list. Here we do the calculation part. So first the name of the file is appended to the list, then the frequency list is. Why we consider frequency list? Because since all our files are of great length, we divide these files into a number of chunks and we find the individual frequency of these chunks and we take this as a list. So the name and chunks, that is frequencies, are appended to L, and at last we update all these values into FFT freq.text. That's all about our program. Now we have here two more functions which we didn't explain before. Here we have wave load function, that is the first line of ifreq, where we load our required audio file. Wave.open frame fname, this is a path of the sound file, and using the built-in function get params from the wave module, we get the n frames, sampling width, and then channels, from which we calculate the required number of frames, and we read those number of frames into frames, and we store that value in the FMT, which stores the values in decibels if sampling width is equal to 1 or higher quantity, that is th, if it is not equal to 1. Then we return the parameters after unpacking the frames. That is what is done here. So here we receive the frame rate, total number of frames, etc. Then the other wave data also, which is here. Params is a tuple, so that tuple is the first argument. The second argument is wave data, that is which is unpacked using the struct module. Then all these concern about finding the FFT algorithm and Fmax index array. It is actually used for finding the largest element in an array. It comes as part of the FFT algorithm here. Okay, that's all. Now let us run this code. Since this code takes a lot of time to process, I have already executed the code. This is the file. First argument is the file name, which is followed by the frequency of different chunks. It's about 100 chunks for each file. Likewise all the files, hundreds of files, thousands of files. Thank you guys. I hope you enjoyed it. If you have any doubts, please post a comment and you will be answered soon. Thank you.